So now we are going to understand some of the important NumPy functions that can be used for statistics. So guys, these important functions include the mean, that means the average of the numbers that are present inside the NumPy array. Then we also have the median, that is the middle number over here. Then we also have the standard deviation and variance as well. Apart from this, we also have the maximum number and the minimum number as well that can be found inside the NumPy array in this case. So guys, let us move to VS Code over here, and then simply I'm going to create a new file. In this case, we will name it as stats function over here. So simply we have stats functions followed by the Python extension in this case. Now guys, the very first thing is we are going to import the NumPy library over here. So import NumPy as np in this case. Now what we are going to do is simply we will say array1, it is equal to np followed by dot, and then let us say we want the numbers between 1 to 10. So simply I'm going to provide the a range as the function over here. The start number is 1 and the stop number should be 11, which is not included. The last number will be 10 over here. And then what we will do is simply we are going to print the original array in this case. So simply we say original array, it is equal to followed by the variable that is array1 this time. Now guys, let me just save this file now. Let us confirm whether we are getting the proper array elements over here. Yes, we are getting all the numbers between 1 to 10 in this case. Now guys, let us see how we can simply provide the mean or the average of all these numbers by using the NumPy function. So simply over here we will say print, and then we will say mean of array, it is equal to, and then within the open and close curly braces over here we can say np followed by dot, and then we have the mean function over here that helps us in order to find the mean in this case. So we provide open and close parenthesis, and simply you can provide the variable that is having the array over here, which is array1 this time. So guys, when we say array1, let me just save this file now and try running this code on the terminal. So as you can see, we have the original array 1 to 10 over here, and the mean of array it is 5.5. Now guys, let me just show you how this mean is calculated by using the calculator. So what exactly will happen is all the numbers will be added first of all, and then we will divide that sum by the number of elements, that is 10 over here. So we do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 over here. So we are getting 55, and what is the count of all the elements? It is 10 inside this particular array. So 55 divided by 10 will give us 5.5 over here, and that is how the mean or the average of a specific array will be calculated. Now guys, simply the NumPy library provides you this particular function in order to quickly calculate the average, so you don't have to add all the numbers and then divide the sum of all those numbers by the count of the elements present inside the array. So this is a very important function in order to find the average of a specific array over here. Now guys, apart from this, you can also find the median as well. So let us check that also. Let me just duplicate this line of code, and simply we will say median of array it is equal to, instead of the mean function we will provide median function over here. As you can see, this is the function, and then as a parameter we have to provide array1 as the parameter. So let me just save this file now and try running this code on the terminal. So as you can see, the median of array is 5.5 once again. That's because it is the middle value when we sort the entire array in the ascending order. So guys, we are going to check another example wherein we are going to randomly generate all the numbers between 1 to 100, and for that particular use case we are going to see what is the mean and the median of the array. Now guys, apart from this, you can also find what is the standard deviation and the variance. So let us provide the another line of code over here. Simply we will say standard deviation this time of array it is equal to, and then once again we will make use of the np followed by dot, and this time simply we use std function in order to find the standard deviation. once again it is going to take the array as the parameter over here. So we simply provide array1 as the parameter, and then apart from this, let us also provide the variance of the array as well. So simply we will say variance of array, it is equal to np followed by dot, and then we have something called as variance over here, var, and then once again we are going to provide the parameter, that is array1 this time. So when we run this code once again over here after saving, so as you can see we are getting standard deviation of array and then variance as well. Now guys, what is the meaning of standard deviation? Basically it defines what is the value by which all the elements are separated over here. What is the deviation between all the elements that are present inside the specific array. And this standard deviation is basically used wherever you are carrying out the mathematical operations over here. Now guys, we are going to provide two more print statements. We will say minimum element in array and maximum element in array. So guys, over here first of all we will define the minimum element. So how do we find the minimum, that is having the lowest value inside the array? So simply we will make use of the min function within the np library over here, and we simply pass the array1 as the parameter, and the maximum element can also be found by using the max function over here instead of min. So guys, simply we say minimum and maximum element in the array, and then the elements will be displayed over here. So as you can see, we are getting minimum element in array, it is equal to 1, and the maximum element in array, it is equal to 10 over here. Now guys, we are going to take another example wherein we are going to get the random elements over here, but before that we are also going to print the sorted array as well. So after providing the original array, we will find what is the sorted array over here. So simply we will have a single line of code in this case, wherein sorted array is equal to, we can make use of the np library followed by dot, and then we have the sort function in order to sort all the elements within the array. So simply we will say array1 as the parameter. So when we run this code once again over here, since the original array is already sorted, we will get the sorted array that will be equal to the original array itself. So as you can see, we have all the elements between 1 to 10, and then we are getting all the other results, that is mean, median, standard deviation, variance, minimum, and the maximum element over here. Now guys, very important thing, you are not going to make use of the sequence in some of your requirements. So what you have to do is, you have to create a randomly generated array over here that is not in the sorted manner. So guys, in this case we are going to make use of the random module within the np library followed by dot, and this time we are going to make use of the rand int over here. So this function helps you to randomly generate the array elements. So let us see what will be the parameter over here. So as you can see, first of all we have the lowest integer that you want to provide. So let us provide the number 1, that we want the lowest number followed by comma, and then it is expecting the highest number over here. So let us say we provide 101 because the maximum number that we want to be included is 100. So we provide one number extra, that is 101, which is not included, followed by comma, and then you can provide the size as well. So this time we are dealing with a one-dimensional array. So what we will do is, we only want 10 elements that will be randomly generated. So over here we provide the number 10 as the size for this particular rand int function in this case. So guys, let me just save this file now. Remember that every time you are going to run this particular line of code, 10 different numbers will be generated and will be allocated to this particular array1 variable, and every time you run, those numbers will be different. So guys, let me just run this code once again over here. So as you can see, we are getting the original array, in this case 50, 93, 71 and so on. All the numbers are between 1 to 100, and then we are sorting the array as well. The lowest number is 25 and the maximum number is 99, which can be seen over here, that is the minimum element is 25 and the maximum element in the array is 99 in this case. The other important things are, what is the average of the array? So basically all the numbers are added and then they are divided by the number of elements, that is 10 in this case, to find out that the average is 56.7 over here. Then the median of the array, it is equal to 54 this time. So as you can see, we have the 5 elements over here on the left hand side, and on the right hand side as well we have the 5 elements. So between 50 and 58 we have the middle number, that is 54 over here, and that is what we are getting the median in this case. And the standard deviation is 24, variance is 620.81 in this case. So guys, in this way you can easily find all the required parameters for a specific array over here. Let me just run this code once again. So a separate list of numbers will be generated, and once again we have the average as 66.2, then the median is 64.5. How? Because the number between 61 and 68, it is 64.5 over here. The standard deviation, which means the deviation between the numbers, is around 20, and then the variance, it is 405.15. The minimum number is 33, as you can see over here in the sorted array, and the maximum number is 98 over here, as can be seen as the last element inside the sorted array. Now guys, what we will do is, let us provide the two-dimensional array over here. So simply we are going to provide a 3 by 3 matrix in this case. So instead of providing just one number over here, we are providing the size as the tuple that is going to take 3 by 3, that is 3 rows and 3 columns. So let me just save this file now. Let us see what will be the output. So when we run this code once again over here, now as you can see, the original array, it is equal to 3 by 3 matrix over here. We are having 3 rows and 3 columns, and then we are also getting the sorted array in this case. Now guys, the sorting is done row wise by default over here. So basically the first row is sorted within the first row of the sorted array in this case. So 29, 52 and 89 is the sorted array, that is the first row, and then we have the second row and the third row. So this is the default behavior. You can make use of the other parameter such as x's in this case. So simply we make use of the x's in order to sort the elements in the row wise or the column wise over here. So guys, this is the sorted array over here, and then once again we have all the required functions, that is the average of the array 58.77, then the median is 68 over here, then we also have the standard deviation, that is 28.47, then we have the variance. The minimum number is 7 over here, and the maximum number is the 89, as you can see from this 2 by 2 matrix. So guys, this is the way that you can make use of the different NumPy functions as far as statistics is concerned when you are dealing with the NumPy arrays over here. So guys, comment in the comment section below whether you have learned something out of this video. Please make sure that you like this video so that it reaches to more people, and subscribe to the channel so that you get the notifications on upcoming videos as well. I'll see you in the next video. Till then, stay tuned.